When dealing with a 3-wire hot tub and the potential use of a ground fault circuit interrupter, or GFCI, breaker in the absence of a neutral connection, there are several important factors to consider. Firstly, it's crucial to verify local electrical codes to determine if a GFCI breaker is actually required in this specific situation. Local regulations may provide exceptions or alternative methods for protection. If local codes don't mandate a GFCI breaker, there are alternative protection methods that can be implemented. One such method is bonding. This involves bonding the equipment framing and all metal parts of the hot tub to the grounding electrode system. This ensures that any stray voltage will be safely conducted to ground, minimizing the risk of electric shock. Another alternative is to use a portable GFCI at the power cord connection to the hot tub. These devices provide ground fault protection at the point of use. Additional considerations include ensuring the hot tub is properly grounded. A bare copper grounding conductor should be used to connect the hot tub to the grounding system. This provides a lower impedance path for fault current to flow back to the source, tripping the circuit breaker or GFCI device. When connecting the wiring to the GFCI breaker, the black wire, which is the hot wire, should be connected to the terminal marked L or hot on the breaker. The white wire, which would normally be the neutral, should be insulated or capped off since there is no neutral connection to the hot tub. A circuit breaker with an appropriate amperage rating for the hot tub should be installed. This will protect the circuit from overcurrent conditions. The wiring should be enclosed in a conduit for protection from moisture and physical damage. This is especially important in outdoor or wet locations. In summary, if local codes do not require a GFCI breaker and alternative protection methods are implemented, it may be acceptable to use a standard circuit breaker. However, prioritizing safety and consulting with a licensed electrician for a professional assessment is always advisable. An electrician can evaluate the specific installation and ensure that it meets all applicable codes and standards. Let's delve deeper into the technical aspects of GFCI breakers and their operation in various electrical systems. A GFCI breaker is designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. The GFCI breaker constantly monitors the current flowing in the hot and neutral conductors of a circuit. Under normal conditions, the current flowing in the hot conductor should be equal to the current flowing in the neutral conductor. If there is a difference of 5 mA or more, the GFCI breaker will trip quickly, interrupting the power supply. This tripping action typically occurs within a fraction of a second, preventing serious injury or death. GFCI breakers are commonly used in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. They are also required by electrical codes for specific types of circuits and equipment. In the context of a 3-wire hot tub without a neutral connection, the standard GFCI breaker operation is disrupted. The GFCI breaker relies on the neutral conductor to monitor the current balance. Without a neutral connection, the GFCI breaker cannot accurately detect ground faults. This is why it's important to explore alternative protection methods such as bonding and portable GFCI devices. Bonding, as previously mentioned, involves connecting all metal parts of the hot tub to the grounding system. This creates a lower impedance path for fault current to flow back to the source. When a ground fault occurs, the fault current will flow through the bonding conductor, tripping the circuit breaker or GFCI device at the panel. The effectiveness of bonding depends on the quality of the grounding system and the impedance of the bonding conductors. It's important to use appropriately sized bonding conductors and ensure that all connections are tight and corrosion-free. Portable GFCI devices provide ground fault protection at the point of use. These devices are typically plugged into an outlet and have a receptacle for plugging in the hot tub. The portable GFCI device monitors the current flowing in the hot and neutral conductors of the hot tub circuit. If a ground fault is detected, the portable GFCI device will trip, interrupting the power supply to the hot tub. Portable GFCI devices are a convenient way to provide ground fault protection for hot tubs that do not have a dedicated GFCI breaker. However, it's important to choose a portable GFCI device that is rated for outdoor use and has an appropriate amperage rating for the hot tub. Grounding is another critical aspect of electrical safety for hot tubs. The grounding conductor provides a path for fault current to flow back to the source, tripping the circuit breaker or GFCI device. The grounding conductor should be a bare copper wire and should be connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod or a metal water pipe that is buried in the earth. The size of the grounding conductor should be determined based on the size of the circuit conductors. It's important to ensure that the grounding conductor is properly connected to the hot tub and the grounding electrode system. Loose or corroded connections can increase the impedance of the grounding path, reducing its effectiveness. When installing electrical wiring for a hot tub, it's important to follow all applicable electrical codes and standards. This includes using the correct type and size of wire, installing the wiring in a conduit, and properly terminating all connections. The electrical code specifies the minimum requirements for electrical installations. It's important to consult the electrical code for your specific location to ensure that the hot tub installation complies with all applicable requirements. Conduit provides physical protection for electrical wiring. It protects the wiring from moisture, physical damage, and accidental contact. The type of conduit used should be appropriate for the environment in which it is installed. For example, rigid metal conduit is often used in outdoor locations where the wiring is exposed to the elements. Flexible metal conduit can be used in locations where the wiring needs to be bent or routed around obstacles. Proper termination of electrical connections is essential for ensuring a safe and reliable electrical installation. All connections should be tight and corrosion-free. Wire connectors should be used to join wires together. The type of wire connector used should be appropriate for the size and type of wire being connected. In the case of a 3-wire hot tub without a neutral connection, the absence of the neutral wire impacts the overall wiring configuration and the selection of appropriate protective devices. Firstly, the absence of a neutral wire means that the hot tub is designed to operate solely on line-to-line voltage. This is common in 240-volt systems where the load is balanced and doesn't require a neutral for current return. However, it also means that standard 120-volt circuits that rely on a neutral for operation cannot be derived from this supply without a step-down transformer. Secondly, the choice of circuit breaker becomes more critical. Since a standard GFCI breaker relies on monitoring the current balance between the hot and neutral conductors, it cannot function correctly without a neutral connection. Instead, a 2-pole circuit breaker without GFCI protection might be used, provided that local codes permit it and that alternative safety measures are in place. Alternative safety measures could include enhanced bonding and grounding as previously discussed. Bonding ensures that all metallic parts of the hot tub are connected to a common ground potential, reducing the risk of electric shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker. It's essential to adhere strictly to local electrical codes and regulations. These codes are in place to ensure the safety of electrical installations and to prevent electrical hazards. Failure to comply with local codes can result in fines, penalties, and potential safety risks. Consulting with a licensed electrician is highly recommended. A licensed electrician has the knowledge and experience to properly assess the electrical system and to ensure that the hot tub is installed safely and in compliance with all applicable codes. The electrician can also provide guidance on the selection of appropriate protective devices and wiring methods. In summary, dealing with a 3-wire hot tub that lacks a neutral connection requires careful consideration of electrical codes, alternative protection methods, and the expertise of a licensed electrician. Prioritizing safety and adhering to best practices is essential for ensuring a safe and reliable hot tub installation. Consider also the impact of a hot tub's electrical requirements on the overall electrical system. A hot tub typically draws a significant amount of power, so it's important to ensure that the electrical panel has sufficient capacity to handle the additional load. The circuit breaker for the hot tub should be sized appropriately based on the hot tub's amperage rating. It's also important to consider the voltage drop in the wiring. Voltage drop occurs when the voltage at the load is lower than the voltage at the source. Excessive voltage drop can cause the hot tub to malfunction or overheat. The voltage drop can be minimized by using appropriately sized wiring and by keeping the wiring runs as short as possible. Another consideration is the location of the hot tub. Hot tub should be located on a level surface that is capable of supporting the weight of the hot tub and the water. The hot tub should also be located away from overhead power lines and other electrical hazards. It's important to provide adequate drainage around the hot tub to prevent water from accumulating and causing damage. In cold climates, it's important to protect the hot tub from freezing. Freezing water can damage the hot tub's plumbing and equipment. Consider installing a hot tub cover to help insulate the hot tub and prevent it from freezing. Additionally, regularly inspect the hot tub for any signs of damage or wear. Replace any damaged or worn parts promptly to prevent further problems. Proper maintenance is essential for ensuring the safe and reliable operation of the hot tub. This includes regularly cleaning the hot tub, checking the water chemistry, and inspecting the equipment. Following the manufacturer's recommendations for maintenance will help extend the life of the hot tub and prevent costly repairs. When troubleshooting electrical problems with the hot tub, it's important to follow safe electrical practices. Always disconnect the power to the hot tub before working on any electrical components. Use a voltage tester to verify that the power is off before touching any wires or terminals. If you are not comfortable working with electricity, it's best to call a qualified electrician to diagnose and repair the problem. Remember, electricity can be dangerous, and it's important to take precautions to protect yourself from electric shock.